Hi, my name is Darcy. I'm the president of IEC Incorporated. IEC means Intelligent Engineering Connections for data stream modeling in structural engineering and structural health monitoring, SHM. Understanding structural internal force would be essential to analyze its stability and tendency of deterioration. By directly measuring the force of load-bearing component will be the best way. But the force measuring equipment is under force all the time. There is no way to take it out and to be put it into a calibration device. The GIGO rule, garbage in, garbage out rule of a digital twin system requires a trustworthy data. It means that self-calibration of load-bearing component is the essential function to ensure the measurement and traceability if we want the data to be used in the structural health monitoring system. That is why we developed a self-calibrating force measurement equipment under load-bearing conditions. We call it BearingSmart system. In this BearingSmart system, a set of two symmetrically arranged wedge-shaped blocks are located between a bottom plate and a special-shaped upper plate. The contact surface between them are supported by sliding material. The vertical force is decomposed into horizontal force. The wedge blocks have a tendency to move closer to the middle, overcoming the frictions. That is fretting friction. In the mechanical equation, three important factors include vertical force, horizontal force, and friction between wedge blocks and plates above and under it. By pushing apart the wedge blocks using a jack, a small jack, the direction of friction will be reversed, but the coefficient stays the same. Therefore, by creating a new state where the frictional force is reversed, we get a binary equation to solve the vertical force and fretting friction coefficient. So does this theory really work? In this experiment, bearing smart devices under vertical force of 150 kilonewton. The load cell integrated with the jack here measures the horizontal force between the two load cells before and after fretting friction is reversed. The system uses simple equation to calculate the average of two numbers. Multiplying the leverage factor determined by slope to be 152 kilonewton, quite close. Reliable self-calibration. Does this self-calibration process change the height of the device? Here, the system recorded the height raised 0.05 millimeter when jack pushes the wedge blocks apart. The height change can be lower to be 0.01 or even lower if we do it more smoothly and slowly here. And after all, 0.05 is not too bad. After this self-calibration process, the height will be going back to normal. Now we have a reliable force measuring device with self-calibration function. So we get the data to be trusted, and we can do much more. One of the things that we can do is to accurately intervene the internal force inside the structure. In this example, 3 BearingSmart bridge bearings are supporting the bridge girder. The system indicates that the force on central bearing is much smaller than the force of the bearings on both sides. We want to intervene. So by pushing the wedge blocks of the central bearing part, the force in the middle is rising and both sides are dropping. By using this method, high accuracy of force intervention can be achieved. The accuracy scale could be 1 Newton's force and 0.0001 millimeter. A control system with restraint of both force and displacement can be deployed, transforming the structure to be really adaptive. Apparently, it is a big step forward from the conventional method, which requires lifting the girder using synchronous jacking, then adjusting the bearing height, and resetting the girder. In that conventional way, the forces are not controlled accurately, and the effect of the intervention cannot be evaluated. BearingSmart system offers another interesting benefit. It supports the replacement of structural bearings without lifting the girder. So by simply deploying temporary supports while making the bearings lowering down, bearings, bearings can be replaced and the new bearings will bear the right force as the control system put it to the right height. The internal force state of the structure could remain unchanged during the replacement process. This process requires significantly smaller and much less jacks. In most of the cases, 90% or 95% less than the conventional girder lift-up method. When dealing with replacing megatonnage structure bearings, the world record of girder lift-up method is 6,000 tons. But IEC alone, my company alone, has supplied more than 30 megaload bearing higher than 10,000 tons. It will be a big problem in engineering world, but BearingSmart is solving the problem. In the video below, we put the BearingSmart system in the hydraulic press and give it a force of around 16,000 tons. Then we measure the force by using the self-calibration process. We also change the height of the system up and down for 10 millimeters. It means the bearings can be replaced and structural internal forces can be intervened. Clearly, the mega machine we are setting up new world records. In conclusion, we achieved breakthrough in one, measuring static force with self-calibration function. Secondly, automatically intervene structure internal force with high accuracy both in force and displacement. And thirdly, replacement of bearings without changing the internal force of structure, which is crucial in megaload structures. We have patented our technology and put it into use in several mega projects. The technology is still evolving. We are closer to our vision of smart structures. So, if you are interested, contact us and see if you can help us go further. Thank you.